Hello, folks. How are y'all doing tonight? All right. Welcome to the March monthly meeting. Glad y'all all made it through this glorious weather we have out here tonight. And let's start things out. I'm Chris Toady, if you don't already know who I am. We've got two presentations tonight, and but I'm going to start out. It doesn't look like we have any new folks that are here tonight that would like to introduce themselves. Do we have any projects that anybody is working on right now that they would like to either update us or tell us about what you're starting into, either one?
We've been at Wednesday at Hot Springs, Solar Eclipse. Solar Eclipse, what's the other? What's the theme? Activities for librarians. And went through training. Space Science Institute has put together a big tub that has a hydrogen alpha telescope for the libraries, a sun spotter, two sinoculars that are 8 by 32s, and then what's the other? Two other that are child sizes that don't have to be focused or anything. Chalk art for them to do the drawings of the eclipse. So for the library to check it out, do programs at the library. And they'll also have then the glasses available for patrons that are in the programs. They can give them free glasses. So we then went to Jonesboro, the same thing. We had the clouds, could not do the, actually have them do the hands-on, but Darcy and I will end up having to help with all that one whenever the kids get checked out. We'll have to go there and help them make sure they know how to use them. The company that put all that together, they were just here for in-service for 3 days this week and then went back. So we'll be at Rosebud Monday night, talk to the city council, do a PowerPoint on Tuesday for the senior group from Christ the King Catholic Church. Wednesday, we meet back with Gen 1 at State Library. We got Old Washington next weekend, same time that y'all have a star party at Woolly Hollow State Park. So I need somebody to run a Facebook page. People keep asking, y'all on Facebook? They want to see the pictures, and Darcy's been really taking a lot of pictures and getting stuff ready that can be material for that.
I'll be there during the daytime. Yeah, I'll be at Woolly Hollow during the daytime with y'all. And then I'm swapping out. Bruce will be there in the evening. How many of y'all are actually going to be there at Woolly Hollow next weekend? Show of hands. We got one. Y'all are going to be there during the day. We got Ed. Ed's on the maybe there. All right. Anybody else? Oh, and National Astronomy Day that's in April, correct? We'll have that together hopefully in the next few days. All right. Is there any other projects that are going on? Other than, isn't the RRT going to be down? The RRT. All right, so it's going to be just a just a tad longer on that, and then we'll have it all up and going, hopefully. All right. Yes, Miss Darcy. Right. Kid is sorry that she couldn't make it up here. And if you get a chance, stop by and see her, bring her a care package. So she's up there at the VA North. And any others? All right. Well, then I guess we'll start out. Sean, if you can let Ed share.
We'll work on sharing screens. Obviously, tonight we're not going to have a Messier mini marathon because of the weather. All right. So you already got me sharing or not?
You should be able to now.
All right.
All right, here you come.
All right. The little Zoom thing's never going to go away. So I'll talk about what a Messier mini marathon is and talk about Messier a little bit. And I'll pass a few things around. One is this planisphere that a guy had made a few years ago to have all the Messier objects on it. And I've got it set for tonight so you can look at it and see in general where things are. It's big enough that you might be able to actually see it and read it. And then here's some books that have things in them related to what we're talking about tonight. One is an old book that was updated over the years by some folks who started including the Messier list in it. Then I've got a little book that was published by Sky and Telescope magazine about the Messier objects. And in the late 60s and early 70s, a couple of guys were looking at all the objects, and one of them sketched the objects and one of them photographed the objects. And Sky and Telescope put it together in a book form, and it's a really good reference, I think. And I don't know about the modern science stuff in there, but it's a good reference for amateur astronomers. And it has a long introduction by Owen Gingrich, who is one of the people who added objects to the list over the years that Messier made. And then this is a really great book right here that goes through all the objects. And the guy who added the last object to the list wrote that book. Here's Stephen James O'Mara's book about looking at all the objects. And here's one that a guy did that has really good pictures in it. So what we're going to talk about is a mini marathon of the Messier objects, but what the heck are the Messier objects? So back in the 1700s, a guy from the country moved to town. He moved to Paris, and he got a job, I believe, as a draftsman, and worked for the French Navy. Well, one of the things that they did was they made astronomical observations to make tables of when things happen in the sky so that they can navigate using the stars. So he started observing objects, and he really liked looking for comets. So he would look for comets in his, I guess it was part of his job, but he did it as he worked there for the Navy. So he observed from the top of a building, and it had a little atrium looking deal on top of it at the time. And I guess you would open the windows and poke the telescope out. but it's a building that's built on top of a building that was a Roman bathhouse, and it's still there. I mean, the Roman building is underneath this more modern building. And Bruce, I took this picture in November, standing there, dragged my wife over there, and we looked at it. And look what's sitting right out in front of where Messier observed a light, but it does look like it's downward firing. Yeah, but it still would have been a mess. So he was observing these objects from Paris, and they didn't have a lot of artificial light, but I imagine that it was smoky and there was probably a lot of dust. So the sky probably wasn't as clear as you think it would have been pre-electricity. He was observing about the time that Ben Franklin invented the street light, I think. That was originally published in the early 1900s, and then the Mayalls republished it in the 50s and 60s and 70s, I think. But as it got older, they put in more stuff, and then eventually put the Messier list. So as this man was up there looking for comets, he had a problem. He would poke around, he would see something, and he'd think, I found a comet. And he'd go, dang it, it's not a comet because it didn't move. So he started noting these things. And the first thing that he noted was the Crab Nebula. And if you ever looked at it, it looks kind of like a comet. And it looks a lot like this comet that we've been looking at this year. When I did the sketching program, I went back and looked at what I had sketched, and I don't know why that thing at the bottom is still there, but on the right side is the Crab Nebula, my little sketch of it. All it is a smudge. I mean, that's all I could see. And I may have looked at that from out here. I'm not 100% sure. I'd have to look back at the sheet. But on the left is Comet C 2019 something 2 Lovejoy. So it was a few years back. And that's that comet on the left side. So this is what was happening to him. He's looking, and I'll talk about his telescopes in a minute. He's looking and looking and looking. He keeps running into these objects, and he thinks he's found a comet. Then he has to watch it, see if it moves. It doesn't move, so he writes it down because he's going to come back across it. He knows that other people are too. And since they look just alike, he wants to make sure that he and other people don't think they have found a comet. So he had a lot of challenges as he observed. He worked for the Navy. He didn't work for down the street. He could, if he was working at the Paris Observatory, I mean, they were looking for objects versus making tables for navigation. So he had pretty limited equipment and limited circumstances on top of that building. He had little bitty telescopes compared to what other people have now, and some other people were starting to build. He lists his telescopes and he'll refer to them. And the thing they did back then is they talked about how long the telescope was. They didn't talk about it's a 90 millimeter refractor. They would say a telescope of 1 foot. And you'd wonder, well, what in the world is that? And you have to piece it together from what he puts down. One of the telescopes he used had about a 7.5-inch mirror in it, and it was about 32 inches long, with a magnification of about 100 times. So I messed with an eyepiece calculator, and if you used a telescope with those attributes and had an eyepiece in it with, I put in a Huganian eyepiece, I think, because that's probably what he was using. And he could only see about 1/3 of a degree at the most if he was looking at that. But a reflecting telescope wasn't as good as a reflecting telescope now because it was made out of something called speculum, which was 2/3 copper and 1/3 tin. You had to polish it. And you had to have more than one mirror and swap them out and go clean them up and shine them up again because they would just tarnish immediately. Just as soon as you shine it up, it would start to tarnish again. So his mirrors weren't that great. Well, then achromatic doublet refractors were invented probably about during his lifetime, but they became more available. And one of the ones that he used that I found references to comes out to about a 3.5-inch aperture and about 42 inches long. So if you put that same kind of limited eyepiece in there, you only end up with about 1/4 of a degree that he's looking at. So he's barely looking at any sky at all. He doesn't have any context. And when you think about comet hunters, more modern ones, they have big fat reflectors or big binoculars, and they sweep. They go along like they're mowing a yard through the sky as the sun goes down, and they need to see more context in the sky. But man, he was doing it with just a dinky little telescope. William Herschel came to see him and saw the conditions that he was working under. So Herschel, he's making speculum mirrors, but you can see one in the Smithsonian. It's this big that went in his about 20-foot long telescopes that he did most of his observations with. And then he built an even bigger one because he built a huge 40-foot long reflector. And he felt sorry for Messier because Herschel had these monster telescopes. Messier sitting there, it's like he bought his at Sears or something compared to the ones that Herschel was using. But one of the things Herschel did was he didn't poach Messier's objects. If Messier had listed an object, then Herschel left it out of his catalog. Yeah, the first several of them. Now, some of the Herschel objects correspond with the Messier objects, but he would leave them off his list as he would find things that Messier had already put on his list. So he was respectful of him and kind to him. So now we've got bigger telescopes. We've got a lot more reflection in our mirrors. We have coated lenses and eyepieces. Those coatings make a big difference. We've got short, wide, telescopes we can see a lot of sky with. And we have great eyepieces now, and we know where to look. So we have a big advantage over what he was doing because he was poking around hunting for those comets and kept running across these little fuzzy objects. So he put his list, and in one of those books, they reproduced the whole deal. I don't think you could stand a chance of reading it, but he would publish this list in these tables and other publications that were put out. And in 1774, he put his first list out that went from the Crab Nebula to the Pleiades. Now, I don't know how you confuse the Pleiades with a comet, but he put them in there, I think, to get 45 objects. So that was 1774. He made that list. Then 1781, he was up to 103 objects. Now, he didn't find all of them, but he put them on his list. He had a friend named, I'm going to pronounce it McCain, who also worked for the Navy and he was a mathematician also, but he did a lot of observations, and they were sharing things, and they had other friends, and they would put things on the list. So he got up to about 103. Then in the 20th century, people who were scholars of science, history, started finding other things where he had noted other objects. And they added these to his list, or objects that had been observed by people who were kind of in that circle. And I'm not even going to try to pronounce the first name, but he added 104. That's the Sombrero Galaxy, I believe, because he found that Messier had noted that he saw something that was there. I have no idea, but I think it's the publishing of the list that mattered more than anything else, because those would end up published. Maybe he just never got around to deciding to put it on one of the lists when it was time to publish, but he had an observation recorded. He may have. 1781, I think, is the year that Herschel discovered Uranus. I think it was 81. So Messier was kind of already going before Herschel was famous for that discovery, and before Herschel became a professional astronomer. In 1947, Helen Sawyer Hogg, who was Canadian, added 3 objects to the list based on scholarship that she had done. And then Owen Gingrich, who's still living, he's 93 years old. He was a professor of astronomy and the history of science and that sort of thing at Harvard. He added M108 and 109 based on observations he found. And then the last one, the author of one of those, the second largest book that I passed around, added M110 because he found a sketch that was made into an engraving. And you've got M31, the Andromeda Galaxy, and then you've got M32, it's another object you can see next to it. Well, M110 is there too. It's a little more like a dot. Carolyn Herschel, she discovered that independently. And then I think William Herschel verified that. And Messier included it on a sketch that ended up as an engraving in a book. So he saw it. So Kenneth Glenn Jones, and he was, I think, worked for the Webb Society or did a lot of their Webb Society stuff. He said that should go on the list because it was a solid observation that he made and recorded. So that's how we got 110 objects on the list. This is one of these pictures. We've got one over here with all the objects photographed and on the wall. Here's the tally on these things. And, you know, there are a lot of galaxies on it, a lot of globular clusters and open clusters and things like that. That supernova remnant is M1. You had a star that exploded, and that's the leftover part. An asterism, I'm not sure which one that is, but a double star, that's M40, which is really confusing because people have said there was some nebulosity out there. And I think the story is that Messier was looking for it and he saw that and he thought, okay, that's what they're talking about. So he noted it. But it's just a little double star. And I think it's, when John shows it later, I think it's Winecki something or other. It's listed on a double star list. And a Milky Way patch, I think that's the star cloud in Sagittarius. M102 is confusing because not everybody agrees that it's a separate object from M101. It is a galaxy. It's on, I think, on that list over there. I know when I observed it out here one night, I thought maybe I just found 101 again. I wasn't 100% sure because I was just hopping around and looking at it. So you've got all these objects. And I think the reason that they've stuck with us this long is because of the size of his telescopes. And he could find those. It's a good representative sample of what's in the sky. And you can replicate it with an amateur telescope easily. Even though when people do a lot of observations, they might use a larger telescope. And I'm about to get to that part. So I think probably these books had a lot to do with this, but in the late 60s and early 70s, there were books about the Messier objects, and people started building telescopes and doing a lot more formal amateur stuff. And in the 70s, a guy named Tom Hoffelder, and you can watch, he made a presentation on this in February to his astronomical club in Connecticut. It's a really good hour-long presentation. He said, hey, look, around the spring equinox, the sun is kind of in a spot where there aren't any Messier objects. So that means the rest of the objects are viewable from sundown to sunset to sun up. You could probably see them all. And he talked to a friend of his named Tom Ryland, and they said, all right, let's give it a shot. So several people tried it and got a lot of objects overnight in the late 70s. Well, Hoffelder wrote a letter to Walter Scott Houston, who had a column in Sky and Telescope magazine, and he waited and waited and waited and waited. And then he gets a postcard from Walter Scott Houston. He typed these postcards and sent them to people. This is his form of writing to people. And he said, hey, I'm excited about this. And then he ended up publishing the challenge in early 1979. Well, Don Mackholtz, who's in this picture, he had been doing it out in California. He'd had an independent realization that you could do it and had his club out there working on that. He was surprised when he saw it in the magazine. And he died last year. Last summer he got COVID and died. But he wrote a book about observing the Messier objects in one night, doing a Messier marathon. And then wanted to note that you cannot use your marathon observations for the Astronomical League program. It's they want you to stop and look at the objects and actually describe them and not just rush through them. So people like Don Mackholz, he could do it from memory. Just boom, 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 and get them. And they'll get their tables, their clubs that have put together tables of a lot of the folks out west have do these marathons because they're really good observing conditions. And you can see the lists of who did it, how they did it, and whether they used charts, etc. Normal people, though, are not going to stay up all night. You're supposed to take a nap and all this other stuff. But once you get on your cot or your bed, you're not getting back up. A guy named Harvard Pennington put together a book on doing as much of the Messier objects you could any time of year. And he had really good charts and a method of finding based on big stars that you could always find and kind of geometrical movement around that. He died, but his friends put the book together and Wilman Bell published it. But he had this program say, okay, in June you can do this, and this time of year, that time of year. And then Astronomy Magazine said, all right, let's break these down into 4 seasonal lists that we can use to have a mini marathon that a mortal person can handle and get to bed by midnight. So they've been publishing those. But Rocky in our club, who can find them, I don't know if he uses charts or not. He's out there just knocking them off. Rocky says Astronomy Magazine's they didn't work very hard on their list. And he suggested a list that he sent out to the club. He's got 35 objects on his, and he's got a different order based on traditional methods of hopping from one of these objects to the other because there's certain tricks and tips. So he's pulled those together. So the mini marathon is a way to take the 110 objects that could conceivably be viewed in one night in the spring, but breaking them down so that you can have fun doing it and not stay up all night and go to 35. And I think that is my last slide. So John's going to talk about the objects that Rocky points out that we should observe tonight, but I don't think we're going to see anything tonight.
Sound is my computer or it's that. Okay. I didn't want to cause a feedback thing. All right, so I need to share.
Hey, Sean. You can set it up for John to share.
Yep, John should be able to share.
John should be able to share. All right, thank you, sir.
Yes, sir.
All right. Figure out what I got going. Getting there. Well, it's been kind of weird. So I guess this is working, right? I'm going. As far as I know, this laptop is not, well, speaker's doing something, but I guess it's working. This is complicated. Okay. So this is Stellarium, and it's a program that's been around for several years. It's a free program. You just download it off the internet. They're always updating it. And I thought, I'm going to check out the latest version and see, what's the difference. And this one, they've added, you have to do Alt B. See that? No, that's because I'm holding that too close. Can you bottom left corner? How do I do that? Bottom left corner. This thing? Oh, this. Your other left. Left. You got to look at the bottom. What come on? I can't do that on here. I can't get there. All right. But anyway, so how this works is you can browse up an object and add it to the list. So I took Rocky's lists and put them all in to Stellarium in this big table. And then you can tell it highlight all, and it will actually show them in the sky, which is a new thing. It never used to do that. So anyway, if you start on a marathon, you got to start right as soon as it gets dark. And of course, there's Jupiter and Saturn. I mean, Jupiter and Venus. And they're going to go down first. And as it gets dark, you have to really catch those first few. This M79, I always thought was the hardest one to do because you have to almost do it when it's still light a little bit. So, no, it's a galaxy. And he didn't have that on his list, I guess. Yeah, I just put the ones that he's got. But anyway, these first few, you pick them up immediately. And, so we've got an easy one. We've got the Orion Nebula, and actually count this little separate part of Orion is a different number. So that's Marian's. I couldn't control the M object numbering thing. They actually give names to everything. That's built into Stellarium. So some of these are a little bit different. Like never heard that referred to as Marian's Nebula. The thing is, the Casper, I believe that's M90. Yep. 79. It's in Orion. That little whiskey piece right above the belt. So that is an M object, and so you're gonna have to pick up these the Crab Nebula, Shoebuckle Cluster. I've never heard that called. That's what they call it. Salt and pepper and pinwheel and starfish and all these things. These are all M objects that are right there. They're gonna go down. So see what happens is as you know, as you fool around hunting all these, this guy's doing this on you, and so you're going to lose those first few. So you got to get them done, and then you start picking up some of these over here along the meridian here, and once you get to the beehive, you're you've sort of done the first wave. And usually I was pretty good at doing this. But once I got past the beehive, usually guess what happens when you get past the beehive? You start looking for galaxies. And now Rocky's list did not put in all the million. There's like 50 M objects lumped right together in coma. I don't have those shown, but the at some point I think in the mini marathon you sort of call it quits, and I think that's why it's just so hard to do the whole thing, because those galaxies, and to make sure you got them all sorted. I never was able to. Anyway, so you get when you get past the meridian and then you're getting into the galaxies and the sky goes on, of course the moons will come up. Eventually then you're working your way around to all the ones that are in the Milky Way, and that's probably getting probably hidden by the sun. Anyway, so yeah, so we're getting into some of the times after getting late into the evening. But in order to do and then of course now it's getting light again. So like he said, there's a gap between the evening and morning where the sun is parked right now, this time where there's really no M objects. So theoretically, you're at, like I said, I've never been able to. And it gets pretty grueling because you just as soon as you find one, you say, yeah, check that box for the next, try to start finding it. Unless you're using setting circles or something. Pretty hard. Anyway, that's really all I had to show here to supplement what we already had. Anyways, what I wanted to do though is I want to show you something I've been working on. It's not directly related to this, but I think it's going to be kind of that's all right. I'm going to do. Yeah. Then it's all right. I'm going to let this switch the screen to my direct input, so these folks can see the graphics. Okay, so what I did was I learned how to write scripts for Celestia. Celestia is super powerful program that's free. Anybody can download it. It's not the easiest thing to learn to use, but it can really be a heck of a teacher. I always thought it was underutilized because it's hard to set up. So I wrote a script. It was painful. I had to learn how to write scripts. I didn't like it. I did. And I can share that with anybody in the club that wants to use this software. It's all automated now. You can actually pause, talk, but otherwise it just carries right on through and sets up all these elaborate conjunctions and things that you want to use to show people. So this one is in particular just showing you, it starts off showing you the Earth and the fact that the sun is only shining on portions of it, not all of it at any given time because of the tilt of the Earth. And so in this case, it's showing you that the polar regions are lit or in total darkness in the summer. The thing that's kind of fascinating with this program is I can take and show you different things. Like right now I've switched and I've made the Earth still, so the whole rest of the universe has to rotate like what we appear to see. So we're looking at what we see because we're standing on an Earth that's rotated. And these are all the different directions that we just take it for granted that that's what we're going to see when we look at the sky at night. Although I think a lot of people are kind of a little bit confused about how that movement takes place. I know when I first got into the hobby, it was a little intimidating. The other thing you can do is you can show things from different viewpoints in the solar system. Like, what would the Earth look like from the moon? Does the Earth have phases? Does it rise and set? And so forth and so on. Actually, the Earth doesn't really rise and set because the moon doesn't rotate relative to the Earth. But what it does do, of course, is the Earth would go through phases just like the moon does. And this shows that. You can also kind of see that gentle rocking on the moon. That's a real thing. And I'll show you more here in a bit. And we're talking about eclipses. The reason that we don't have an eclipse every month is because the moon's orbit is tilted by like 5 degrees. So you can see here where it's going above and below the plane of the solar system. And what that causes to happen is when we look at this screen, we're going to see what the moon's orbit looks like when we line the Earth up with the sun, is that the moon goes above and below the sun relative to our viewpoint. So most months, it just doesn't happen. And then when it is lined up, maybe the moon is not in the quite right spot because it's zipping back and forth. So everything has to be just right. It has to be tilted correctly, and the moon has to be in the right spot. And it's just a close-up version of the same thing. So it is kind of amazing that we have as many solar eclipses as we do, because the moon is really not set up to line up very often. There's mud so far. Goes. But if everything does line up, or a very limited location on the Earth, you get to see the moon actually cover the sun. And we will, of course, have that coming up next year. Almost just a little over a year away now. So all these different scenarios, it's all in this program is running this in real time on my computer. It's not just something I've made and play back. Did you see the shadow passing over right there? It went kind of quick. That was actually, it rendered the shadow of the moon. So anyway, that's the eclipse. Now I'm covering just some of the rest of the planets going out through the solar system. We'll go to Mars next. And little Phobos is so small, it's not even round. And it orbits very close to Mars. So it actually orbits faster than Mars rotates, which is really strange because it means that Phobos rises and sets the wrong way. I wish they had it where you could click and say, okay, I'm ready to go to the next thing, but they don't really have it set up like that. Talk about it. Here's another interesting thing you can do with it. I've actually told it to magnify Mars as if my telescope was at Earth. And I'm going to show you what Mars would do over time if I was looking at it with the same size telescope. And of course, it tilts, it changes tilts, it gets bigger, and then it shrinks smaller again because we're on an Earth that's rotating the sun separately from Mars and getting further and closer to the planet. And so all this geometry is changing. This is just showing you that Mars is retrograde, the fact that it goes backwards or appears to go backwards. And kind of a similar thing to what I just did, except now I don't have it magnified as a telescope. It's showing like a vision. Now, what I'm trying to do is show you why it does it. So here I have a little mark there for Earth, and there's Mars. And see, as we lap it, it's actually it's an illusion that appears to go backwards just because we're on a moving planet. Here's a telescope version of Venus. I don't know how many times y'all have tried to look at Venus, but it has some really nice phases that you can follow, and it gets very large when we pass. It actually passes us in this case. It's in the inferior planet, so right about the time it gets really big and really small crescent is about the time it goes into the glare of the sun. The Mercury is an odd one. They used to think Mercury was locked to the sun like the moon, but it apparently is not. It has a 3-2 resonance. Like every 3 orbits, it rotates twice, or it rotates 3 times every 2 orbits, or something like that. They call it a 3-2 resonance. And what it does is really strange because of the orbit being so elliptical. It actually stops the sun from time to time, and you can kind of see why it does that there. It's rotating constantly at that speed, but at some points the sun actually kind of stalls out and doesn't continue progressing around the planet. Saturn, what do you say? That's a pretty gorgeous rendering. Now what we're doing is we're following one of the moons. This is Enceladus, I guess you'd say. Enceladus, thank you. Enchilada. We're right on the ring plane, so the rings are just thin as paper. They're really not, but on the scale, the size they are. They're very thin relative to how big they are. Remember the little shepherding moon? This is Pan. He keeps that inky division cleaned out by orbiting in there. If he didn't, it wouldn't be there. They call him a shepherding. He shepherds those ice particles out of the way. Iapetus is the one that's two-tone. It's the yin and yang. It's got two different kinds of material. Now what we're doing is I'm changing the focal length of my objective lens and zooming in on Saturn. So I'm doing a telescopic view again. And what I can't do with the telescope is sit there and look at it for 12 years. So we're going to do it as if we could. And you'll notice it does this interesting nodding thing. That's because we're on a planet that's going around the sun as we look at Saturn. And so it does this little nod thing. And then finally the rings become edge on. And you always can gauge how long you've been in this hobby by how many ring plane crossings you've witnessed. Because it only happens every 12 years. Because Saturn's year is 24 years long. And of course, with Jupiter, you know, you got to watch a shadow transit, right? And this one's Ganymede. Ganymede, Jupiter's tilt is very close to matching the solar system. So they have a lot of shadow transits. You can have a shadow transit on Saturn, but they don't happen nearly as often. That's just if you were inside the shadow looking back, you'd see an eclipse again. This time it's Ganymede eclipse. And there goes Jupiter, right? I can hit my camera. So then we go out to Uranus, the next planet out, which was noted William Herschel discovered. And there's all these moons. I mean, it wasn't known when I was a kid studying the solar system. All these moons weren't known. These have all been created, all these little bitty ones. They've all been discovered since then. And there's a whole slew of them. I couldn't tell you them all their names, but this is one of them. And then the other thing that came out of some of the space probes was the fact that Uranus had rings. They're very faint. They're not like Saturn's rings, but they are definitely there. And so can you see them on there? Yeah, I guess they show. And then there's some darker ones there that are coming in. It kind of does a little bit of a jig jag. You're reaching the limits of his rendering. It's amazing software. It boggles my mind. Do it for free. So I'm just kind of following this little moon that's sort of embedded in the rings, and telling the camera to keep it in the picture, and then just letting moving the camera, dollying it back. Titania is one of the larger moons. By the way, we saw some of the moons with Bill Ingberg's giant telescope one night. I couldn't believe it. The first for me. The Triton is the largest moon of Neptune. And the Neptune has that big kind of spot thing, or at least it did. And then finally, of course, we now have imagery of Pluto because, and yes, I'm going to call Pluto a planet. I'll never switch. And because of the horizon, and the chair on the little moon back in behind is locked to it. They both face each other constantly. So there you have it. Probably 100 hours of work in 15 minutes.
You full of physics?
Well, the program handles all that. It has all that in it.
You're a director.
Yeah, you're just telling it what you want, but you have to tell it very specifically what you want. In script. Yeah, yeah. You have to tell it, put the camera here, follow this moon while you look at this moon or look at this planet, then ramp the time up. And you have to tell it everything because it doesn't know what you want. Yep.
All right, thank you, gentlemen. Does anybody have any questions? No questions.
Well, planets that, are closer to the sun are inferior, whereas planets that are further to the sun. I guess am I saying it right, Tim? Okay. What are the outer planets? Superior? They're superior. Yeah, I think they are. They're inferior and superior. Are the sun?
Folks, and we would call it a wrap for this month. Say thank y'all for all coming out. And it's wonderful weather we have out here tonight, and it's good to see y'all. Don't forget, we've got Woolly Hollow coming up. It's not this week. It's on the 18th. We're all for correcting my date on there because I tend to get lost on this. We look forward to seeing y'all next month, but definitely up at Woolly Hollow between now and then. Thank y'all.